Hello everyone, this is Mr. Perry. So I want to make this video doing more demonstrations of electrostatics. And this video is also going to be pertaining to your lab this week. So that's the main reason why I'm making this video. And I'm going to be doing several demonstrations of electrostatics. And from these demonstrations, what I want to do is inspire you as you make your own videos or your own own videos of electrostatics and demonstrations of electrostatics. It's going to actually this video is going to be a part of your lab this week. So, and I also want to point out that this for the class that I'm making this video for, which is Physics 110A, your lab is actually technically not due this week because it was a holiday at the beginning of this week, which is July 4th. So therefore, your video is actually going to be due next week, okay? So, or lab rather, in the video with the including the video is included in the lab. That's going to be due next week. So everyone, let me see if I can get this on camera. So put this in the say again. I'll put myself in the background now, and this little thing you see here is full. It's a jar full of styrofoam. Okay, small pieces of styrofoam, or really styrofoam-like particles. And you saw this video. You saw a video of this previously, say in the class Physics 110. But I'm gonna do it again, and this time I'm gonna use this charge wand. Okay, so with this charge wand, basically how it works, it's a small version of the Van de Graaff generator. And what a Van de Graaff generator basically does, it builds up static charge. You're saying by using an electric motor connected to a belt. And that belt is connected to a set of rollers. And what happens is those rollers rub against the belt, or the belt rub, say either way you look at it, the belts rub against the rollers and the rollers rub against the belt. But what happens is that static charges build up as a result. So that's what I'm gonna do here. So I have a small version here. And as I press the button, you see pieces of styrofoam. Let me go to the side here. You see the pieces of styrofoam jumping around inside the jar. So, and the reason why that is because each piece of styrofoam is being charged up, and because they have, let's say essentially the same charge on each individual particle. What happens is in the same amount as well as the same polarity, and that's the main thing, polarity. What happens is that they're going to naturally repel each other because, as you already learned way before you ever took this class, negative or positive charges, when they face each other, we have positive facing positive and negative facing negative. Like charges repel. Whereas, of course, unlike charges, like a negative facing a positive, they're going to attract. And that has a lot to do with the nature of the electric fields, which I'm not going to get into in this particular video. So you have this demonstration. And everybody, again, what happens is you don't have, I'm guessing, I'm going to take a wild guess to say, you don't have one of these at your house. So what you can do instead, which is easy to obtain from a hardware store, get you a piece of PVC pipe. Okay? A lot of times people use PVC pipe these days, they're saying for plumbing. So this stuff is really easy to find. But what happens is, everyone, is that PVC pipe, it makes use of what we call the triboelectric effect. Let me actually put this on camera. Okay, hopefully you can read that and move this out the way. So everybody, triboelectric effect essentially is about charging with friction. So what happens is, just like how the Van de Graaff works, you have a belt rub against some rollers. This motorized belt rub against rollers and building up static charge by using friction. What happens is, because the nature of the PVC, the chemical itself, the nature of it, nature of that compound, if you rub it, against a PVC surface, that's a good way of building up static charge as well. So I'm gonna take this piece of paper here and rub up the PVC pipe. Actually, paper's kind of hard to use. Let me actually use a cloth. All right, let's try this thing again. So, put the voltage storm back on camera. And it's charged up a little bit. You can see a little, it's kind of, well, I can see it. We see some particles of saying in there a little bit. And everybody, what I'm saying is this: you can actually replicate the voltage demonstration by, taking, again, pieces of styrofoam or some other, maybe small pieces of paper, taking some PVC pipe, charging it up by friction, and you can actually see the same effect as I did earlier. Let me try another piece of PVC pipe. Let's try this. So, yeah, getting something. Naturally, it's not going to work as well as the charged one. That's the reason why I got a charged one to begin with. Why any instructor would use that. But you see, I can build up a little static charge with it. Let's try some pieces of paper now. And let me angle the camera down. Let me go ahead and rub this up. Angle my camera down here. That's kind of actually hard to see. But everybody see how that piece of paper had a hard time, it didn't slip off the PVC pipe at first? That's because the PVC pipe is charged up. Now let's do it another way. Let's do another demonstration, an even better one. That one didn't quite, pan out, as far as build up enough static charge to really make, for you to see it kind of great demonstration. So let's take this plastic bag instead. I'm gonna do two things with the plastic bag. This is another demonstration you can do. Anybody can actually obtain a plastic bag from pretty much anywhere these days. Unfortunately, I say unfortunately because plastic is aiding to a lot of pollution these days. But plastic is relatively easy to obtain. So this relatively easy to obtain plastic I have in my hand is actually a trash bag. So what happens is, let's say I would do this: take this trash bag and rub it a few times against the wall here. You do again, each one do at home. Notice how now the bag is stuck to the wall. And the reason why is because by me rubbing the bag, I remove charge by rubbing, the bag like so. And once I remove some charge, this allows the surface to be charged up. And now this charged up is now attracted to the surface, being the wall, because it's attracting, the unlike charges in the surface of the wall. So now the bag is stuck to the wall. And it's going to take a while for the charge to, charge to return to the bag to such that it's going to fall off the wall. Okay? I can pull on this thing. You notice how, check that out. This thing's really stuck to the wall. You can also hear some popping noises. And notice how it's still charged up because when I pulled it off the wall, it now has attracted to my uncharged arm. So the wall was uncharged, and now I pulled it off the wall. My arm was uncharged, and that's why it stuck to my arm. Almost like a piece of tape. Okay. And speaking of tape, so another thing too, you can see this thing still got some charge to it because see how it's being attracted to my hand, like so. By the way, I could take this thing, use the PVC pipe, rub it against the PVC pipe, build a lot of static charge, pick up some stuff like paper, things like that. Unfortunately, where my camera angle is, you can't see it. But everybody, one last one I'll put out for this video, actually, next to last one. You can also do charge demonstrations using tape, okay? So take any piece of tape, Scotch tape works best. But, because like I said, the reason why I say it works best, I really should say it's easier to obtain. So take a piece of tape, all right? Put the tape down, do what you do with tape, attach it to some surface. Now remove the tape very quickly. Notice how the tape was attracted to my finger? See how now the tape is attracted to my finger? Because what happens there by the nature of the tape, what makes tape sticky is this is actually a result of electric charges, what makes tape sticky. By the same token, friction is the force itself is actually a result of electric forces. Okay? You have electric charges, reacting to each other to give rise to friction. So by the same token, adhesion, that's the result of electric forces or electromagnetic forces, the way you talk about how adhesives work, you know, glue, tape, and things like that. So let me take this down, this piece of tape here, put this back down. I'm gonna get another piece of tape. All right. Now what I can do is put these on a surface, like I normally do with tape. All right. Make sure the tape does not loop around and like saying you have a hard time removing it. But I'm gonna take both these pieces of tape. I'm gonna remove both of them from the table. And tape is kind of notoriously hard to work with, so that's why this demonstration is often frustrating. But note how the pieces of tape are not actually trying to touch each other. They're trying to avoid touching each other up until I get to that point. Okay. So at one part of the tape, they have the same charge. They're light charged, so therefore they repel. But other parts of the tape, one's positive, the other one's negative, and therefore they attract. Okay. So, but see if you can do that. See if you can actually come up with a demonstration where you can actually make the tape either, like say again, light charged or unlight charged, and you can actually see charges, like say again, light charges attracting, and unlight charges attracting, and light charges repelling. Okay, my last one, I'm going to exclude for this video. This another thing you can do. You can take I took two tin cups and I put a magnet and have them now attached to each other. You have a magnet here and a magnet here. And because those magnets, now these cups are together. I was going to do this thing where if I were to charge up the PVC pipe, by the way, I can. The good thing about PVC pipe, I don't even need a cloth. I can rub my hand against it and that will remove charge. But what happens is I don't think this camera angle is going to work. And I say I have one more demonstration, but apparently, me being long-winded, I got more demonstrations to go. But you see how those cans start to move towards the PVC pipe? Again, not the best camera angle. So, therefore, I might actually say for this video, I'll probably just nix that one. But still, this one doesn't work out well, let's say again, because camera angle. That was a problem. Let me try this one with the water. So what I did was I took 2 cups here. One of these, the styrofoam cup on the top has a hole in it. So when I lift this thing up, and I already put water in this top cup, see how the water's dripping? Okay. So let me charge up the PVC pipe one more time. Okay. Let this water drip. You see how the water's dripping? Now watch what happens. I'll put the PVC pipe near it. So I was getting trapped a little bit. Okay. Let's charge up again. I might have lost some charge probably. And the charged one works better with this because I don't have to worry about keeping this thing charged with the charged one. So let's say again, the stream gets slightly attracted to the charged up one. So, charged up pipe. Let me try the wand this time. You see more easily with the wand. So everybody, those are demonstrations you could do. Let's say the ways you could demonstrate electrostatic saying charges. And electrostatic just simply means stationary, saying electric charges. Okay? So electrostatic charges, they are stationary electric charges. So again, if you have questions about this video, let me know. If you have questions about the lab this week, also ask me that as well. So everybody take care and have a good day.